Recall the experiments of Hertz and others that we discussed earlier, where beams of light were shown on polished metal surfaces. The results that they obtained were that electrons were only emitted above a certain frequency of light, and that the kinetic energy of the electrons would increase with the frequency of light. This plot summarizes the types of results that Hertz and others got. This kind of graph cannot be explained with wave theory of light. It shows that light is made up of particles, photons, and it's not a wave. What we see in these plots is that light with a frequency less than a cutoff frequency F0 will not emit electrons. We also see that light with a frequency greater than F0 will eject electrons up to a maximum kinetic energy dependent on the light frequency. But why? Why do we see electrons emitted only above a certain frequency? Well, it turns out that not all of the photon's energy goes into the electron's kinetic energy. The electrons are bound to the metal, so a minimum amount of energy, called the work function, is required to free them. So the equation for the maximum kinetic energy of the emitted electron is actually very, very simple. The kinetic energy, the maximum kinetic energy, is simply the difference between the energy of the photon hitting the surface and the work function, the amount of energy taken to free the electron. Ke max equals hf minus w. So, negative w is just the y-intercept from the graph that we saw before. All of the observed properties of the photoelectric effect were explained by Einstein's work, this one simple equation, and for that he received his only Nobel Prize. So, Einstein successfully reintroduced Newton's idea that light is composed of particles. It's the only way of explaining the photoelectric effect. But now we're left with some phenomena of electromagnetic radiation that are explained only by assuming that light is a particle, and some by assuming that light is a wave. So, what is it? We'll return to this question later in this unit. But for now, let's take a step back and look at another example of particle nature of electromagnetic radiation.